beautiful list. Oh, you don't look very, are you okay? We can talk later. Welcome to science. At this particular point, thank you very much, Jose. Thank you, Brandon. If you could secure your devices, I greatly appreciate that. Is it started? It is. Thank you. Hello, home people at home. Today is Wednesday, January 11th. So at the very top of your notebook, please put Wednesday, January, or not Wednesday, but just put January 11th. Here's your question for the day. So if you could write this down, thank you for securing that. I appreciate that. Make sure it's not buzzing, though, and distracting you. Write this down as your question. Your question in your notebook for today's date should say, the Eurasian plate and the Pacific plate are both moving in the same direction. So why is there a convergent boundary between the two plates? That is what I am asking you to write down. Just to get your notebook out, write this down. Okay, you don't have a notebook?
No, I do.
Okay, that's fine. All right, so while you are writing that down, I want you to know that we are recording today so that if you need to watch this again, you can. I am going to be quiet, which we all know is super difficult for me, and then I'm going to take attendance while that's happening. Will?
Yeah?
What you got down there?
Notebook.
There you go, man. All right, so I'm going to freeze this. Oh, it is frozen. I'll take attendance, and then we'll talk about our seating chart and blah, blah, blah. And again, I know I'm supposed to be quiet, and I'm having a hard time with that, so here I go. Has anybody seen Ebony today? All right. That's pretty good. We've had enough time. Before we start sharing with our pair share partners, dang it, Alexis is stepped out. I want to introduce you to another Alexis. Everyone say hi to Alexis.
Hi.
Oh, that was so lame. Alexis, where are you coming from? Nice, nice. What part of Iowa is that? North, south? By the Mississippi, away from the Mississippi? Away from the Mississippi. So welcome. Unfortunately, Ebony, your pair share partner is not here, but Rebecca and Ella are right behind you. Not Ella. My God, I'm so sorry, Kendall. My apologies. That's Kendall. I apologize. That's Rebecca. This is William. And your pair share partner is not here also, and for the life of me, I can't put my finger on who that is. And then your pair share partner is not here either, so I apologize. We got some illness in the building. I want to talk about getting to know people around us because every time we do a seating chart change, it's like I've put you with people that you've never seen before. And so what we're going to do, right? What we're going to do is we're going to get to know the people that are around us, and we're going to find out a little bit about them. And so I was like, what can I share about these people? There's Alexis. So what we're going to do is we're going to find out who your favorite or what your favorite Girl Scout cookie is. And so I'm wondering, did I already miss Girl Scout time for cookies? I did? Okay, so I want to know if you've never had a Girl Scout cookie, that's cool, but we're going to go ahead and share out. So find out with your pair share partners who your favorite girl or what your favorite Girl Scout cookie is. And if you could share Rebecca and Kendall with Alexis, that'd be great. You've got 10-second countdown. Find out what their favorite cookies are. On your mark, set, go.
I was not. I didn't want to say. I didn't want to. I think I just like and then I just never went to those meetings.
All right, 3, 2, 1, and we're done. Ask Alex what her favorite.
I don't know.
They were convening.
Okay. All right. Favorite Girl Scout cookie. Have you ever had Girl Scout cookies? What's your favorite? You don't have one. I like the Samoa. Does anybody know what the Samoa is?
I don't know the name.
Coconut, caramel, and the chocolate ones. Those are my favorite. And then my second favorite is the shortbread. And then my third favorite would be the peanut butter sandwich cookies. Rebecca, favorite Girl Scout cookie? The peanut butter cup ones where they've got that's a good one. Kendall, Thin Mints. You've never had a Girl Scout cookie. Justin, the Thin Mints? I don't know what a Girl Scout cookie is. Dang it, I'm bringing in Girl Scout cookies.
Never had one.
Never had one. Never had one. Thin Mint. Thin Mint. You never had one. Never? Thin Mint.
I've never had a Girl Scout cookie.
The what? The s'mores. Okay. Never. Thin Mint?
I don't know the names of any of them.
Okay. Give me like a flavor.
I've had some, but I don't remember which ones.
You don't remember. Just chocolate? Anything with chocolate?
The same one as you.
The Samoa?
Yeah.
The coconut and caramel and all that yummy goodness? Never had Quiet? Thin Mint. All right, so it looks like we need to experience some Girl Scout cookies in here. I will see if we can get our hands on some Girl Scout cookies and we can see which ones we like. Now that we know a little bit about the people that are around us, hopefully it'll be easier for us to maybe share out and not distract each other. I'm worried about that. It was either like, do I put you two in front or do I put these two in front? And so I went with these two, hoping that you two and that. Well, I had to go with this because she can't see and she doesn't wear glasses.
Dang, she just exposed.
I did expose you. All right, let's go ahead now with our pair share partners. I'm going to put 27 seconds on it. Let's see if we can figure out what we've got here for why is there a convergent boundary in this location if they're both moving in the same direction. Your time starts now. Ready, set, go, go, go.
I don't even know what boundary is.
I'm disappointed in you.
Me too. You. Right then there.
We'll make that a bit bigger.
That's the same thing. It's really
All right, there is our timer. So I'm going to ask Billy if you wouldn't mind moving that camera in this direction. I'd appreciate it. What I want us all to do, please, is draw this picture along with the question. A rectangle, we're going to divide that rectangle like this. Up here, I want you to write that this is the Eurasian plate. And then down here, I want you to write that this is the Pacific plate. So I need you to write this, please, in your notebook. And then we've got, let's imagine that this is our compass rose. This is north, this is south, this is west, this is east, and then these two plates are going northwest. So they're both going in the same direction. All right. First things first. What does this represent?
Movement.
The direction it's moving.
The direction it's moving, and what else?
Speed.
The speed it's moving in. So we've got the Pacific plate. Are you back this way, darling? Could you move it back this way? We've got the Pacific plate. There's the direction and speed it's traveling. And we've got the Eurasian plate. That's the direction and speed it's traveling. So now with your pair share partner, talk about that as to why that's a convergent plate boundary. On your marks, get set, go. Turn and talk. All right, 3, 2, 1, and we are done. Billy, if you wouldn't mind turning that one more time over this direction, I'm going to now go ahead and on our picture, if you could please add arrows to represent what we've got going on. Pacific plate is moving in that direction at that speed. Eurasian plate is moving in the same direction, but at a different speed. Slower speed, faster speed. Now, let's remind ourselves that this is a convergent boundary, so I'm going to write the word convergent on this boundary. And let's remind ourselves what that means, because tomorrow you're going to have a little 4-point quiz about boundaries. And so let's remind ourselves what a convergent boundary means. Yep.
They're converging.
They're converging, which means what, smarty pants?
They're coming together.
They're coming together. So why are these coming together if they're both moving in the same direction? Did we have an opportunity to talk that out?
No.
Okay, let's imagine now that this is Nikayla, and she is driving 70 miles an hour down the road. This is Zai, and she's only traveling 30 miles down the road in front of Nikayla. What will happen if Nikayla is driving 75 miles an hour, just bump that up, and Zai is only driving 30 miles an hour in front of her? Turn with your pair share partner, what's going to happen? On your marks, get set, go.
I'm going to fly off the side of the road. Yep. Can't even drive to get.
I'm coming back.
I can't drive.
All right, 3, 2, 1, and we are done. What's going to happen in that driving situation? A fender bender. They're going to crash, collide, come together, which is a convergent boundary. They're going to converge because this is moving slower. Eurasia plate would be like, I'd like to get out of the way, but the Pacific plate is moving much faster. So we have a convergent boundary, and we've got an area of subduction right here. That's why. Now, I don't want you to write this next thing down, but I want to ask you another scenario. Turn it back this way, darling. Here's my next scenario. Let's see if you can figure this out. Imagine, if you will, if the Eurasian plate is moving like this and the Pacific plate is moving like this. They are still going the same direction. Is this also going to be a convergent boundary? No. Turn with your pair share partners and tell me why or why not. Ready, set, go. Three, two, one, and we are now done. Let's imagine Kendall is now taking a trip with Peyton, and they're supposed to be following each other, and they're going to San Francisco, California. Peyton is driving at this speed. Kendall is driving at this speed. What's going to happen on this trip? Who's going to lose her? Who's going to lose who?
I'll lose Kendall.
You'll lose her. Why?
Because I'm going faster.
So you're going really fast. So what's going to happen to your car in relation to Kendall's?
It'll be farther ahead of hers.
Yeah, it'll be farther ahead. It's going to be pulling away. So what kind of a boundary would be in the middle here in this situation? Divergent, dividing, moving away. You've got a divergent boundary. So even though they're moving in the same direction, it depends on the speed of the plates as well. Notice today we're adding critical thinking, right? We're thinking critically. It's not just about the direction, it's also about the speed or the magnitude of how they're moving. Does that make sense? I need a thumbs up or a thumbs down, please, on that. Great. All right, so then what we're going to do, if you could please, get out what you had yesterday in my class. We're going to get to what you picked up today, but let's start with what we did yesterday in my class. Yesterday. Turn it over and let's look at the questions on the back, please. Get out yesterday's. I know you're working on another thing, and I appreciate your determination. You're amazing. Did you get out yesterday's?
Yeah, if I can find it.
You're so snotty at times. Do you realize?
Yeah.
That's it. All right. Let's go ahead and look at the back. First of all, is there anybody in here that would like maybe... That's your warning. Don't even. Is there anybody in here that would like more time in the back with maps? So then let's talk about the first question on the back. The first question on the back, you can't see this. Number 4, it says answer the following questions using your map. So A, are most volcanoes found in random places, or do they show a trend or a pattern? Are most volcanoes just found randomly everywhere? There's one, there's one, there's one, or do they form like a trend or a pattern? Where do we see most volcanoes? Turn with your pair share partners and share that out, because you were not with these people in your groups. See how I do that? On your marks, get set, go!
Like the west side.
Rebecca, could you please tell me, where did you find most volcanoes located? On the boundaries of the plates, on plate boundaries. And they're in a, what's called linear pattern. It's good that they're in a linear or line pattern because they follow the boundaries. Isn't that amazing? They follow the boundaries of the plates. On the USGS class map, locate the Pacific plate. We already did this. Which direction was it moving? What type of boundary do you think is located between the Pacific plate and the Eurasian plate? Now we know the answer to this. What kind of boundary is that?
Convergent.
It's convergent. It's convergent because one is moving faster than the other. So that's a convergent plate boundary. What kind of volcanic activity was at that boundary? High level of volcanoes were there or low level of volcanoes were there? Were there lots of red triangles or not a lot of red triangles? Did we not answer those questions? Was there a lot, Payne, or not a lot?
Wasn't there a lot?
There was a lot. There's a lot of volcanoes. When we have two boundaries that are coming together, there's a lot. There's either going to be mountains, volcanic mountain chains, or there's going to be volcanic island chains, which basically are the same darn thing. It's just that the islands have their little, mountain heads sticking up above the water. So there's volcanic mountain chains. All right. We found Iceland. What kind of plate boundary is running through that country based on the arrows that we saw?
Divergent.
That's a divergent boundary also. Divergent. What level of volcanic activity was happening there? Lots of volcanoes or lots of volcanoes again? High level of volcano. Were those eruptions pretty recent or were those volcanoes really old?
Recent.
They were very recent. We also had some old ones, but they're very recent. Those are fresh, new, currently erupting volcanoes. Now it says, let's go to the very last question. The very last question on this. Suppose tomorrow a volcano forms somewhere in the United States. Would it be likely to form in or near Iowa? Turn with your pair share partners and say yes or no, and then be able to explain why. On your marks, get set, go. Think about what Rebecca said earlier. Dun, dun, dun.
I would not hear any.
3, 2, 1, and we are done. Billy, volcano in Iowa, yes or no possibility?
Because it wouldn't be close enough to us when most volcanoes are on the west coast anyway.
Okay, so I believe what he said was no, low possibility. Is that correct? Low possibility. And the reason why? Coop, why not? Why not in Iowa? What did we find out? Where are most volcanoes located? On the plate boundaries. Not just on the west coast of North America, but the west coast of North America is a plate boundary. They're located on plate boundaries. Is Iowa, Kendall, on a plate boundary? Hell no, it's not. It's right in the middle of a plate. It's right in the middle of a plate. And so that's your evidence, okay? There are no plate boundaries near Iowa. None. Iowa's right in the middle of a plate. Now that I've said that, that's weird, because if we look at G says locate the small cluster of volcanoes that are right in the middle of a plate. What? How can volcanoes happen in the middle of a plate? First of all, what kind of islands are these? Do you know what the islands are? They're the islands of Hawaii. And we are going to today examine why, yes, it's true, most volcanoes are located on plate boundaries, but why is it every once in a while we get volcanoes that pop up right in the middle of one of the plates? It'd be like, you know, volcanoes all around the edge of this table because there's cracks and the magma can come up. That makes sense. But why all of a sudden would one happen right in the middle of this table? Today we're going to go ahead and look at that. So if you would please get out your TOC, Table of Contents, and we're going to go ahead and fill in what you picked up on the way in today. We usually try to organize ourselves by writing things down into the Don't worry about filling anything in. We'll just go ahead and write it on the number that I'm about to bring up. Because good students are great students when you are organized. So I'm going to go ahead and make this small. It is period 3. There is our TOC. So we're going to be on, I believe, maybe number 15. Today's date is 1/11. So it's 1, come on pen, you got this. I believe in you, 1/11. If this was 29 and 30, this is going to be page 31 if you are still numbering. And we are on something called Mantle, am I spelling that right? I am. Plumes. Mantle plumes. Okay, first of all, what in the world does the word mantle mean? Somebody other than Asa. Mantle. Mantle, mantle, mantle. What do we know?
It's the thingy between the crust and the core.
The thingy between the crust and the core is a good place to start. I'll take it. Yes?
Asthenosphere.
Yeah, specifically the asthenosphere is the upper part of the mantle where we have convection currents happening, and that's what's driving the plates. So the mantle is the area between the crust and the core, and that's where magma comes from. All right, a plume. What the heck is a plume?
Something going upward.
It's something going upwards. A plume of smoke, a plume of water. In this case, it's going to be a plume of magma. It's a large amount of magma. So let's go ahead and have this piece of paper that I asked you to get out in front of you, and let's check it out. Oh, did I not copy that over? Miss McGray, just unprofessional. Where is it? 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 I don't have it. All right, let's look at it here. It says, first of all, what the heck is a mantle plume anyway? Well, let's look at each word. The mantle is a layer of earth below the crust. Good job. Alex got us started on that. It is made of semi-solid rock, kind of like silly putty, that can move and flow underneath the surface or the plates. A plume is a whole lot of magma that rises and creates a big bubble of hot rock in the crust. You are going to be following the tale, Will, of this Hawaiian mystery. Why is it that these Hawaiian islands are in the middle? The first thing here says the islands of Hawaii are found in the middle of the Pacific Ocean, like really in the middle. There's nothing around them except the ocean, of course. The first thing, it says make a doodle. What's a doodle? Just a drawing. Does it have to be a good drawing? Nope. Just a drawing of 7 islands in the middle of the ocean. And so make one of them the biggest because it's the island of, I think the largest one is, yeah, I don't know what the big island's called. But go ahead and make 7 different islands. Color anything you want. If you want to color these, you can. I put colors for you on your table. If you don't want to do colors and you just want to go ahead and use your pencil, you can. After you do this, you're going to read and move on to the next part. So this is a work at your own pace. Isn't that nice? That's what you're doing. So go ahead and make your doodles. If you have questions, if you need like clarification, reach out to the people that are around you and be like, hey, what'd you think about this? What is this? Or who else can you call on? No, not calling Ghostbusters. Who else can you call on? Me, but first, could you please reach out to people and then I'll give you clarification if you need it. So you are working at your own pace. I've got the maps back there if you need them. I want to let you know, very important, listen to my face. I want you to know that on, ouch, I want you to know that on Canvas, I have placed for you the periodic table of elements that you can open up on Canvas. Okay, so you're going to need your Chromebook. And then I've also got the Ring of Fire map. There's going to be a Ring of Fire map that you're going to need to look at one point also. Okay, so these are all linked on Canvas. Questions on that? So you're going to need to get your Chromebook out in order to help you with certain things. I'm here for you if you need me. Make sure you're not on your phone. Make sure that you are actually where you're supposed to be, man. You're not even on the right page yet. There you go. Way to get your crap together. I love you. All right, so your time starts now. You're working. Whatever you don't finish in class, guess what you have then? Homework. So get to it. I'll put one of my favorite, don't give me the, gross, because it's a
Boy.
gross music.
You think I'll ace the test if I study this? Like so?
Where's the camera? I want to say
Has
goodbye.
anybody ever heard of the Commodores?
I don't know. But I listen to my own music.
Yeah, you can listen to your own music, but I want you to be able to talk with your pair share partners.
Okay.